Hi everyone, my name is Thomas Mäder. I work for Red Hat, where I lead the Che languages team. I'm glad a couple of people found the way here, and most of which I don't even know. Interesting. My team at Red Hat does a couple of things you might know. For example, the Java plugin for VS Code, which is based on a language server which is called JDT LS.
Hey, this time the holy.
And recently, for example, we have published a VS Code plugin, also based on a language server for XML, done by our intern. Excellent work, by the way. Check it out. We have Anatoly here, who wrote the debugger for Che IDE on his own until recently. And but we're also responsible for the whole language server protocol support in Eclipse Che. And that's what I'm going to talk about today. So the challenge we had in the last year is that Che used to have a Java language support, but it was based on a fork of Eclipse Java tooling, JDT Core basically. And we wanted to replace that with a implementation based on JDT LS, because the fork we had was basically unmaintained for a couple of years. It didn't support Gradle like JDT LS does. It didn't support Java 10, 11, whatever is going on. So we wanted to put that on a basis where it can be maintained, and we profit from the development that we do once in JDT LS. So the purpose of this talk is actually to present the extensions that we did, because Che has support of Java beyond what LSP offers. LSP basically is something in the editor. So if you want to do stuff like browse Maven dependencies in your Project Explorer tree, that's not covered by LSP. And I'm going to present what we did, so people who might be interested in doing LSPs or language servers by themselves, doing extensions with them, can kind of know what we ran into and not make the same mistakes, hopefully. All right, agenda. We're in the middle of the intro, and basically the next thing is going to be that we go through the extensions we did, kind of present what kind of calls we had to implement, and the challenges we ran into while doing them, and the common problems you need to solve if you want to do that. So first let me ask you, does anyone use a product based on a language server protocol, like Eclipse Che, VS Code? Okay, anything, Atom, Vim, or whatever? Okay, that's good. Second question is anybody familiar with LSP on the protocol level in programming? Oh, wow. That's cool. So for those who didn't hold up your hand, I have a one-slide intro, what LSP is basically. You have an IDE, the user comes and clicks .control space because he's at a certain, let's say, a class name, and he wants to know which class names could be there or which methods could be called in that class. So it pops up the little control, the code assist, but what does it show there? The IDE doesn't know. It needs some component that understands the language, for example, Java or TypeScript, and needs to know there are classes, how do you parse them, AST, etc.
That's not cool.
The problem is if you have M IDEs and N different languages, you're in the problem that you have to implement N times N, the language support for each language and for each IDE. So what to do? First thing is, let's make a process, call it language server, and put the whole language smartness thing on the other side. And because you have like a boundary now between the two, you can actually share between IDEs, you can share the different language servers, and you have a mix and match approach, so it becomes an M plus N problem instead of an N times N. And you talk at the standard protocol between the two. Yes. And the second thing is, which is implicit kind of in LSP, but which is necessary, is that you have access to the source files of your project, because contrary to what some people think, LSP doesn't actually transfer files or anything. It just talks about open files most of the time. So you need access to the same the same files to actually feed the oracles that can tell you what the smart thing to do is. Okay, let's have a quick look at what an LSP actually is. This is a text document definition. Let's have a quick look how this looks in, yeah, here we go. Where's my cursor? Here's my cursor. So I've got the pet clinic sample. Many of you might be familiar with that one. I open the person thing, and I go here to the class, the person extends, and I press F4, which is go to definition. And what does it do? It goes to the definition. Not very surprising. So let's go back here. Sorry, this is not.
Closely
so what's in an LSP call? If you look at the thing, it has two parameters. The first one is a URI, and it's URI to a local file on disk. That's why we need the shared file access, because it's gonna point to something on local disk. And the second thing is it's a position, and the position given as a line index and a character index in that line. And if you look at the replies, there might be multiples, but this is just the case where it's only one definition, and you get back another local file URI, and you get a range, which is two positions, start position, end position. Not very interesting. The interesting thing here is that there is no mention of any types, there are no methods, there are no whatever function calls, there's nothing. This is just talking about text and only text, files and text, files and text. And that's one of the reasons why LSP can be so general, because it doesn't talk about the languages, it talks about interactions and files and text, and that's what you handle when you have a text editor. There are a couple of exceptions, like symbol kind and everything, for those who know, but mostly it's true. So what's missing that we needed for that to implement the Java support? And it's things like exactly browsing
whether you do
Maven dependencies in a project tree. It's things like opening references which are not in source files but in binaries, etc. And what we're going to do is actually go through these and have a look at them, what they entail. So we had in Che, we had all that. This is kind of old style Che. We have the IDE, and we have a part called Workspace Agent, which runs on the backend, and which actually is the backend of the IDE. And there's like a JDT core instance from Eclipse JDT core, and there's custom code that implemented all those extra features that go beyond LSP. And our approach was actually to lift that code, mostly, if possible, unchanged, and move it over to the JDT LS instance, which also has JDT core, so that's convenient. We should be able to reuse most of the code.
Two groups.
All right. The advantage, of course, is that we can get rid of all of the Java-specific code in our WS agent, which makes that smaller, and we can start the other thing in a container, etc. Everybody's happy. So let's start with the first thing we did, and that's also present in VS Code, and that's actually the ability to open non-source files. And I don't know, in TypeScript or wherever, this might be a rare case, because you always have the source, but in Java it's very common. Again, if we look at this, where's my cursor? Here's my cursor. Let's say I have integer here. And the integer is not in the source file, it's in the somewhere in the JDK. So if I do again my F4, you can actually open that and you can see source code. But there's no source code. So what happens here is the first thing we had to do is actually, if you do LSP calls like definition, like the one I showed you first in the source, we need to return something that points to something that's not in source code, but in the JDK somewhere. So and you've seen that we need a URI, and that's the first thing we need to do. Well, we need to get away in the references or definitions. We need to get away from the file URI, and we need to define our own URI format. And this is actually a copy from a request, actually opening string class, I think,
was more or less,
obviously. And you can see that you can't see much. It's very complicated, and you don't want to start parsing this. And it's actually also meant to be completely specific to JDT LS. Nobody else is supposed to understand it. Second thing, it's supposed to be opaque, so don't start parsing this. I shouldn't even show you that. And the second thing is that we showed source for something that doesn't have source, and this is where we reuse the whole, because JDT LS is basically an Eclipse instance, a headless Eclipse instance, so we use the whole mechanisms for M2E, for example, which can download source files and attach them to binary files in the backend. So we just reuse that. JDT LS actually has a contribution point where you can add source providers for binary files, and so obviously we have the source attachments that we get from Maven, but there's also a very simple decompiler that just says, I have no source, here's the structure of the class file. And the last thing we'd like to do, and this is another demo I want to do, is actually that we make, not only can we look at references, but also, if I'm in here, the LSP functionality still works. And also we inherit that from Eclipse, because Eclipse knows how to handle all kinds of requests inside the class visualization of source. All right. Where's my cursor? There we are. So next thing we did was actually browse project dependencies, and again, this is something, if we go, cursor please. In my pack clinic, this is a Maven file that has a couple of dependencies here, and if you see that in the project we did a node here. This is not very surprising. You can know this from your favorite IDE, and where do we have a JUnit jar, for example, here, and we can browse what's in here, and for example, open the task class. So this is kind of what we had to implement for this, and it's basically two calls. The first is like, if I have a project, whatever a project means, I can ask it, what are the jars that are on your class path? And the second thing we did is get jar entry. We chose to do this as like with a jar ID and a path relative in the jar, but you could do that very differently. You could, for example, use URIs for all the things and just say get child, get child, get child. But that's really something historical for us. It's not really clear that you have to do it that way. And we get two things back, and that's also a choice we made. The first thing is you get Java elements back, like packages, and you get class files, which have the same URI that we saw before in the references call or the definitions call, and we get folders and files. And this is Java specific, so that's kind of a weird. We could also, for example, just get the file structure in the jar and do something like a file system, but it's not what we chose to do. And again, challenges here is like as I talked about the how to ID non-file entities, which may be in jars, which may be folders, things like that. And we have to make sure that we never pass the URIs to somewhere else than the JDT LS, because they're probably going to just explode if you give them a thing like we saw on the slide before. All right, and the next thing is like cooperation with other language servers. The thing is, because we have those URIs which are specific to JDT LS, other language servers, like, again, let's have a quick look. In here we have a manifest file, or we have a, sorry, it doesn't really want to open, yes. And you can open that, but if I had a language server for manifest files which could do control space in here and tell me what to do, that wouldn't work because it doesn't understand that URI, which is LSP, JDT LS specific. So that's something, room for improvement here, definitely. And the last thing here, which we need to look at, is actually, this is a Maven project, and we have a single external libraries thing here because this is a project. But if this was a multi-module project, we could also browse down here and we'd have a project here again. And the notion of what a project is in this case Maven specific. So we need a certain synchronization between the language server and the IDE or the client to know what is considered a problem. Yes.
Yeah.
How are we doing?
You think
Yes, ask it. I'll shut you down if it's too complicated.
without having synchronized, we just live in a different way. So
no, we haven't, because JDT LS already had that format from the beginning, and we never really changed it. And I think the VS Code plugin actually does parse the URI. It's kind of shouldn't do that. But yes, it would make sense to, if we used defined and agreed upon. We're going to see that later. What? Okay, sorry. Yes. No, it's fine. Shows you're listening.
we can do other.
All right. Here we are. So, next thing is rename, and you might, those who are familiar with VS Code are going to tell me rename already exists in VS Code. Right. But we're not talking about the same thing. We're talking about something like you have in Eclipse, where you have parameters and the where's my cursor? Yeah, here it is. No, not test. I need a source file. If I will rename. So in VS Code, what you do is kind of like you have that.
So here, webs
doesn't. Okay. In VS Code, what you have, I'm doing Shift F6, which is rename. You have to rename that is like this. It's basically a linked mode thingy, or it's better visible here. Now Shift F5. Sorry. But it restores the state. Awesome. So if I do a Shift F 1, 2, 3, 4, 5, 6. There you go. You can actually see that it highlights all the instances of that symbol, and if you rename it, it's going to rename the thing. But if I do Shift F6 another time, it actually opens something like this. And remember that for a second. I'm going to go back and go to the no. I'm just going to use the friggin'. There you go. Refactoring, rename. That is odd. Okay, somebody file a bug. Why is it doing show references? No. That's what you get for live demo. Oh, fuck. Now I almost killed myself. So we're here, and I'd like to do refactoring, rename. Let's see if it works that way. Yes. So we get the dialog, which has, first of all, it has all kinds of references, of options here, which you can't do if you just have an interaction in the editor. Second thing is, it shows me, or it should show me somewhere, that I actually can't use this name because it already exists. So if I choose something correct here, it's going to show me, well, you can do preview. So I'm going to go to the preview thingy, and I actually see in the validator test, I need to change all these things, and I can select changes to be applied or not to be applied. You know all this from Eclipse or some other IDE. And also the last thing is that we actually rename the compilation unit, which was not present before in LSP. You could only do text changes inside the files without changing them or deleting them or adding anything new. So one of the problems here is that actually what we're looking at is a very interactive process. Like, it's not like you do an interaction and then a command goes out and some reply comes back, but you have to, there's kind of like a session that's going on. And it starts with a prepare, because if you remember, when I prepared the file, the dialog looked the field, the dialog looked different from when I renamed the type, because the options are different. That's the first thing we have to do, is kind of like, what's there, what can we do? The second thing is for the linked mode rename, we have to know where the symbol is actually referenced, because it's not a text search, it's actually something that understands that it's a field and it's this exact field, not something that's just called the same. There's like validation, if I want to rename something to something that's already existing, or something that's not a valid Java identifier or method name. The last thing we had to implement is actually kind of like a compute method, which gives us back a workspace edit. And the workspace edit is something that you might know from LSP, which is a set of changes in a set of files. And what we did as an extension was also to allow moves, rename, moves, adds, deletes, structural changes of files, which has now been merged into LSP proper, but it wasn't present when we started. Okay, and so I think one of the challenges here was actually where to keep the session state, because typically in Eclipse this is done with a session, but the thing that was most important for us was the workspace edit, which kind of is the thing we send around to keep our state. All right, next thing is next thing is actually move. I'm going to this is very simple or very similar. It also has like initial, we need to know where can we move a type to, for example, or where can we move a package to. We need to validate when we edit something in the dialog, and the last thing is again the compute. And the good thing is that we can actually get a workspace edit back as well. So the whole preview and apply logic is completely reused from the rename, and we can do that for all other refactorings that we want to do. And the challenges here were a bit, because it's basically a straight port of what we had before. So I think the protocol we use is kind of iffy and could be improved, but basically it's very much like the rename which we did first. Next thing, specific searches. And specific searches, but this means, for example, we have a launcher for tests in Che, but in order to know how to launch tests, you need to know where the tests are, and for that you need to understand the code. For example, we have a file structure, but you can also show the inherited members in the file structure, like you can do in Eclipse. And also that is a specific search that we do over the code. Other things are supertypes, subtypes. There are many things like that. And as an illustration, I kind of showed the search dialog from Eclipse, and you can see that you can have all kinds of options, etc., PP, and all kinds of different searches you can do, which is not part of LSP, and we had to implement a couple of them. And the last thing I want to talk about, and this is has nothing to do with the protocol in itself, but it's a problem we ran into when we import Che and Che. Che is a couple of thousand files, and JDT LS starts blowing up pretty much immediately, because it needs like 3 gigabytes of memory to parse that. But a large problem was that LSP actually mandates that the client does file watching, and you send all the language servers, you send change notifications. Problem is, when you import a project with, let's say, 20,000 files, you're going to get 20,000 notifications, and it takes kind of a long time to process all that. Couple of things that LSP could do better would be, for example, logical batching. Like if you do a project import, it doesn't really make sense to start parsing the code before you have the whole project, because you're not going to find half of the code that you reference. Also, the one thing is that it doesn't have any notifications on folders, only on files. So you basically have to reconstruct the folder tree from the file, which is not a problem if folders are not important. But an empty package is something in Java, which it might not be in TypeScript or other languages. And the last thing is that, you have single requests and they're totally not compressed. So if you could actually send some more compact representation of the change, like a delta tree does in Eclipse does, that would be probably help a lot with the congestion. All right. Yes. So this is already the things I want to talk about in breadth. So a couple of things we found. First thing is it's usually quite simple to do those extensions because first of all, you already have an LSP, so you already have the oracle that can tell you about the language. In JDT LS, we have JDT Core, which does the parsing, AST. You can ask it lots of things. So asking it a couple of different things is usually not that hard. Second thing is generality is hard. As an example, we tried to get a supertype subtypes request into LSP proper, and even on the first day, people from different language communities, they didn't understand what supertypes and subtypes meant. They thought it was something different, and then you start talking about what should the request and reply, what are the options, the parameters, what's necessary, and it's not quite simple it's simple to do a language-specific extension, but to do it generally is quite hard. I think that's one of the reasons why LSP is relatively restricted. But, and that's the last thing, one of the reasons I did this talk is that I think standardization would be desirable. And it comes back down to the URI format. If we have, for example, supertypes and subtypes, or functions make sense in our language universe, then we should get together, and if we have extensions to LSP which don't make it into LSP proper because they don't apply there, it's VS Code after all, we should talk to each other and actually at least agree that we use the same kinds of extensions where it makes sense for our specific domain. All right. And that's all I have, really. So, any questions? No one. I should have planted someone to ask some questions. All right. With that, there are a couple of other talks. We are here now about Eclipse Che, etc., mostly from Red Hatters, I think. So go check them out. They're usually good. I'm going to check out some of them. I'm going to stay here actually for the next one. And the second one is a call to, they ask us to evaluate the sessions. So give me a like or give me a thumbs down, whatever, but give me something. Okay, and with that, thanks.